and welcome to another episode of The Plausible Claus. My wife and I, Mrs. Claus, take much pride in opening up the North Pole for questions and concerns that people in the world may have about Christmas.
That's right, dear. And as you all may know, before we decided to deliver presents to good little boys and girls, we were always fascinated with science. We have found that most of the answers to your questions are related somehow to science.
So now we're going to open up the lines for questions.
I'm going to put them on speakerphone.
And here's our first caller now. Hello?
Hi, Santa. You know, I happen to have one of my reindeers of my own at home, and I really want him to be like Rudolph. I just can't seem to get his nose to glow.
Well, you see, your reindeer's non-glowing nose is actually a sign of a healthy reindeer. When our Rudolph started having his nose glow, we were very worried. Rudolph's nose glows because of a parasitic respiratory infection. Here we have a normal reindeer with a black nose. Once infected by the parasites, his nose becomes inflamed and red. The terminal bones in his nose are elaborately folded and covered with blood-rich membranes. But if you are really concerned about having your reindeer's nose glow, you could try buying a glow stick to attach to his nose.
A glow stick? Well, how do those work?
Well, when a glow stick is broken, a glass ampule inside of it breaks. This results in a reaction between an organic oxalate and hydrogen peroxide. This reaction puts the product in an excited state. The product then loses energy to go back down to its ground state by giving its energy away to a fluorescent dye in the stick. The dye releases the energy by glowing.
Oh, okay. I see. Thanks.
And now for our next caller. Hello?
Hi, Mrs. C. I'm going to be cooking at home on Christmas, and I'm really nervous because I have no idea how to make a flavorful tender turkey. Can you help me?
A turkey gets its flavor from inosine monophosphate and monosodium glutamate. Inosine monophosphate comes from the decomposition of ATP during cooking, and monosodium glutamate is the sodium salt of a naturally occurring amino acid in the turkey. So, to get a flavorful turkey, we have to heat its center to at least 70 degrees centigrade. A turkey becomes tender while cooking because the muscle fibers contract at temperatures of about 80 degrees Celsius. The contraction snaps some hydrogen and disulfide bridges, allowing a more open conformation of proteins. But cooking too long makes the proteins build new chemical bonds, toughening the meat in a process known as coagulation.
Scientists also experimented and found that when you heat your bird so that its center is 70 degrees centigrade, you also get a tender, flavorful bird.
Well, thanks, I think.
Oh, look at the time. We have time for one more caller. Hello?
Yes, Santa, or whoever you are. Me and my friends don't believe in you. I mean, how can you possibly deliver all those presents in just one night, huh?
Well, maybe you'd better let me take this one, hon.
Well, let's answer it together. It's hard to explain how I'm able to deliver all of these presents to good little boys and girls all over the world in just one night.
That's right. But all of you non-believers out there don't know what Santa is all about. We used to not be able to explain Santa's deliveries either. But since a man by the name of Albert Einstein came along, that has changed. He developed the theory of relativity, and when Santa and I read it, we got some great insight into what happens every Christmas Eve.
To get all of those presents, I have to travel very, very fast. I even need to travel faster than the speed of light.
Santa, his sleigh, reindeer, and all those presents are matter, and matter cannot travel faster than the speed of light. But if Santa could travel faster than the speed of light, time would dilate and space would contract, and while for us, time and space would remain the same. The theory of special relativity would give Santa ample opportunity within his reference frame to deliver those presents in what is the blink of an eye for you and me on Earth.
That still doesn't answer how I travel faster than the speed of light. But Einstein also helped us realize that even though matter cannot travel faster than light, there is no limit to the speed that space can travel. In our workshops every Christmas Eve, our elves create a special small bubble of space that holds a sleigh, reindeer, presents, and me. It's invisible, but once we are inside, we are now part of space, not matter, and we can travel at superluminal velocities.
By superluminal velocities, Santa means faster than the speed of light. So you see, he does travel faster than the speed of light. And for him, time would get larger and space would get smaller. This type of travel is also what keeps him so young and gets you and all of your presents every Christmas Eve.
That's right. But just like the view of Santa and Christmas change as boys and girls grow older, so do the theories of science. This year, Mrs. Claus and I were reading the September 2001 issue of Discover magazine, and we found an interesting article that may give us even greater insight into my ability to rapidly deliver presents.
David Deutsch believes that Max Planck's theory can explain overlapping realities. He thinks that our observations are not enough to explain all of the possibilities for the multiple states in which matter can exist. An optical test first performed by Thomas Young in 1801 showed that light has a dual nature. It can behave like a wave and like particles. But the results of this experiment are confusing and indicate to Deutsch that photons in one universe are interfering with photons in another. Can Santa be in many universes simultaneously? Is Einstein's theory the last and best possible explanation for his speed?
Find out next time on the next episode of The Plausible Clause.
But until then,
Merry Christmas to all, and to all a good night.
good night.